right, I'm back, and now let's talk about the abundance of the elements in the universe. So if you were to go into outer space and sample some of the material that's out there, so I know that you're saying, well, it's outer space. Well, even in outer space, there's elements floating around out there. So if you were to grab some outer space, you would notice it's mostly hydrogen and helium. So if you put those two numbers together, you notice that it's like 99%. So 99% of the universe is hydrogen and helium. And then there is other elements in outer space, it's just that there's not as much as there is hydrogen and helium. Now let's look at the Earth as a whole, which has the same composition as an asteroid. So if we were to take an asteroid and look at the elements inside of it, we would find that it's mostly what? So look at those numbers there, and you'll notice that it's about 35% iron, and then it's about 30% oxygen. So those elements are a lot inside of an asteroid. Now let's look at the crust of the Earth. So the crust is the upper layer of the Earth, and let's look at the elements that are found there. Do you notice that one of the elements which was plentiful in the Earth as a whole, it's not plentiful in the crust of the Earth? Which one is it? It's the iron. So do you notice that the iron is greatly diminished in the crust? Where did it go? So you should know the answer to this. Iron is very dense, so it flowed to the core of the Earth. So what does that leave us with? So what are the two most important elements found in the crust? So which ones have the biggest numbers? It's going to be oxygen and silicon. And those two elements are going to go together to make silicates. So silicon and oxygen goes together to make silicates, and they are going to form the backbone of what's referred to as the silicate minerals, which are going to make up a tremendous amount of the minerals and the rocks that make up the Earth. Now that last column there shows you what is it like, what's the moon made of, and you should notice that it's kind of in between the composition of the Earth as a whole and the crust, and that was because the moon formed as a collision between an object about the size of Mars with the Earth, and then that material got blown into space. Well, it wasn't really a direct hit. So if it was a direct hit with the Earth, you would have expected part of the core to go into orbit, so there'd be a lot of iron, but there's not. So that kind of explains, again, the origin of the moon. So this shows you the abundance of the elements, again, but this shows the charges on those elements when they're ions. So do you remember that everything in column number 1 of the periodic table, all of those elements, they like to lose their electron and they want to become positive ions. So if you look at some of those ions over there, the ones that are positive, you'll notice that they come from the left-hand side of the periodic table. On the other hand, the ones that are negative, they're the ones that like the electrons, and they're on the other side of the periodic table. So again, these are going to be the building blocks of the minerals. So I just want you to see that certain elements have certain charges when they're ions. Okay, let's take a break, and when we come back, we're going to talk about the silica tetrahedron.